Starting up. Hello, everyone. We'll get going in just a couple minutes. Probably after I kick the cat out, because you know how she is. How's everyone doing? Let me pause all these video streams coming back in. Awesome. Say hi in the chat so I know everything's working. Hi Mark. Hi Kim. Hi Max. Thanks for joining in. If you're not on YouTube, please say hi on Twitch or Twitter so I can make sure that that is working as well. And I feel bad. Last week I kind of missed the live broadcast chat. So hi Bruce from Discord. If folks want to join our Discord, you can chat there all week. It's the URL adafru.it/discord. I think I'll kick the cat out just since we're getting going here, because she tends to not like me talking. Hi, girl. Meow. You want to say hi to everybody? Can you meow? Meow. Meow. Meow, kitty, meow. No. Of course not. Cats never do what you want them to do when you want them to do it. She meows all the time, just not on command. Alright. Oh, I'm gonna move this. Cat is in charge. She'd love to be in charge. For sure. Okay, is that below? Sorry, I had a friend just drop some stuff off, so I'm a little smidge behind. But that's okay. This is a deep dive. Okay. What will be today? Oh, thank you, cute cat. Dawn says it's working. Hi, Max, Dawn. Thanks again. Mark's at a hotel, so may lose connection here. So, yeah, let me get started here. I've procrastinated long enough, and I think everything's working. Oh, and I'll do my offline screen just because I like to. Hello, everyone. My name is Scott, and I work for Adafruit on CircuitPython. Adafruit is an open source software and hardware company based out of New York, although I am remote, located in Seattle. And they're an awesome company. They support me working on CircuitPython along with others. So please support them. Go to adafruit.com. They're trying their darndest to get everything back in stock, but they are shipping normal orders. So support me, support Adafruit that way. Fede2 says hi from Costa Rica. And that cat that I just kicked out is Vin, V-I-N. Hi, Jim. Hi, Johnny. That is, since we're talking about cats, Vin, who I just kicked out, has a brother, Spook, who's asleep in the window here, and he does have seizures from time to time, so if you hear hissing, that's what it is, and I'll just like mute the mic and watch him and then get back to streaming once he's done. He should be fine. It's kind of what he does. Let's see. The Discord, if you want to join our Discord, which is a chat that lasts all week long, you can go to adafru.it/discord. We have a code of conduct that we moderate, so it's a nice, friendly place for everyone to show and share their projects and get help with their projects as well. So check out our Discord if you're not on our Discord yet. And what else? I don't know if there's any other housekeeping. I do this normally, this stream on Fridays at 2 p.m. Pacific, which has just passed. So if you're here live, then you found the time. Fridays, and it runs about 2 hours. depending on how my voice lasts and how hot it gets in here, especially during the summer now. I do have the window closed because they're doing some like landscaping stuff that they, of course, just started right before the stream. But once it gets quiet out, I'll open the window up and give me some fresh air. Pretty much all the live. Okay, so that's this deep dive. So what we've been doing, what I generally do is I kind of recap stuff at the beginning and then do any sort of work that I think would be interesting on the stream, which I think today is going to be a bit of your choose your own adventure sort of thing. I have like 2 things in mind that I could start. I may not actually get to those as well because what I've been doing is chronicling my progress on the CircuitPython port of the ESP32S2. But I usually do a recap at the start and then I do whatever I'm working on. But I have a package here and I wanted to do kind of an unboxing. But I don't actually want to show the box because it's got like my address all over it. But there's a box here. And it's from Seed Studio. So I figured we'd start with that and talk about the stuff I got in the Seed Studio box. And then we'll talk about kind of where I've settled at on the networking APIs and kind of cover the changes I've made there. And then if we have time, we'll the 2 kind of options I'm thinking are either I can continue working on the APIs because they're not working fully right now, or I can start to bring those APIs to the ESP32S2, which would be like editing the C code to start to introduce those. So those are the 2 options. We're not going to do those right now. Mark has a spoiler in the YouTube chat saying Weo, which is definitely something in this box. Clevon on Twitter asks, is this a VLSI stream? Oh yeah, one thing I forgot to do last week, and I'd love people to remind me, is if I forget to change the title on places besides YouTube, please let me know, because I recorded last week as a John Parks workshop, according to the title. I think I remembered everything today, and I was meaning to create myself like a checklist to make sure that I got everything before the stream, but I'm not sure. Or I don't think I didn't actually make the checklist, so maybe I did forget anything. But it seems like you can see me, you can hear me on multiple platforms, so that's a good start. Okay, I'm just going to open the window right now before we get going. It looks like they're out of the thing. So the thing is that like this room is on the 2nd story and it just gets a lot of sun all day. And so it gets pretty hot in here. And we don't have air conditioning because in Seattle, it never gets that hot. So really you just have to suck it up. And of course, oh, the sound is synced. Perfect. That's great. Especially because I do have the overhead going. So I figured I would do the overhead for the unboxing stuff, and then we can kind of get rid of it after that. Okay, so let's talk unboxing and let's talk Seed. So Seed Studio, for those of you who don't know, is a pretty popular company based out of China, and they make lots of really interesting and cool devices and software. They've done a lot of Arduino stuff, and they had come up with like a fork version of CircuitPython that they were calling ArduPy, which is pretty interesting. It's kind of like merging Arduino and CircuitPython together, which is really interesting. And they released this device, which I guess I'll just start with because it is something. Okay, let me switch to the overhead. And sorry for losing the chat. The only chat that we're still seeing, you should still see, is the live broadcast chat. But I can see the other ones off screen. So this is the first thing that I got, and figure out what my orientation is here. So this is right side up for me, but it looks like it's sideways. So let me just, I think if I do that, now it's upside down, and then I can hit this and it's right side up. So it's the Wio terminal, and maybe we should actually try this. I don't know. That could be kind of cool. So what this is it's a, let's look at the back. It's an Atmel or a microchip SAMD51, max frequency 200, which is not, we don't have that configured for CircuitPython yet. Hi, Sam from Discord. They have external SPI flash. They have a wireless chipset that is also not supported by CircuitPython yet, although I heard that they're working on it. Hopefully they're okay with me saying that. It has an LCD. It's got Type-C USB 2.0, SD card, accelerometer, and some other stuff here, which is pretty neat. And so they announced on the seed forums that they were going to have ArduPi support, but some folks went on there and asked them for CircuitPython as well. So that the seed engineers have been working on that, and we've got that merged in. So let's just open this up and take a closer look. I like that this is kind of like in a proper case. I think that's pretty neat. Let me stab myself with scissors on the stream. Let's just take a look at this, and maybe we should get it going. I don't know. But they did like the initial pull request, and they just like hooked up the display, and I was like, hey, do you want to like set the configuration so the display comes up automatically? So, oh, it's so tiny. It's smaller than I expected. So can you see that? So it's got nice protective cover on it. And then in the box here, it's got a short A to C cable. And I don't know if that's actually like USB 3 compatible or not. It's got one blue dot, which I'm not sure what it's for. They also have a user manual here. And that seems to be it for the box. And it's in English, Japanese, and German, which is awesome. Look at that. Nice user manual. Yeah, so I think this Wio terminal is pretty interesting from the perspective of like being kind of a like more, you know, like less of a bare board and more of like things that are all pieced together. There's a pinout diagram, which is neat. And hopefully these names are what match the thing. So there's the Japanese then. And I guess I should also say, I purchased this myself. Adafruit will probably reimburse me if I ask them to, but Seed did not send this to me. So, but I'm pretty, you know, I tend to collect hardware boards anyway, especially those that can run CircuitPython. So I'm just happy that they've been doing the work to get it going, which has been great. If you are an engineer in China, and I keep telling like people to go to the Discord, I did actually create a WeChat account. So WeChat's a hugely popular chat program in China. And so I have a WeChat account just under Tan Newt. So if you are a Chinese engineer watching this and want to get like chat help, we do have a group going for CircuitPython. All right, so this is what it looks like. And I don't even know what happens when it turns on. What it does when you turn it on. Maybe it's charged. I don't even know. I kind of just like flipped there's like a slide here. I guess I could have read the instructions. And this is actually a button, which I didn't realize from the pictures, but it's a joystick here that is like 4 directions, and you can press it down. And these are Grove connectors. So in terms of Adafruit system, like, yeah. So David says, sweet, you got the Wio board. And then Johnny says, Scott the Hoarder. And don't say that too loudly because it's more true than you think. If you've ever seen before I switched my desk around, I have like a Commodore 64, a Sega Game Gear, Atari 800 all here that I like at some point wanted to do stuff. So yeah, and then there's actually this cool window here in the back that is pretty neat as well. And then this is just like a two by whatever header for all access to all the pins. So it's a really neat little case. It didn't do anything when I Mark's saying I should read the manual. Let's see what it says. Okay. Powering up. Connect the provided USB Type-C cable to the Wio terminal. Before you start, you need a computer with internet access. They've got the Internet Explorer logo there. So I do have a... The problem is I think both these Type-C cables I have here might be a little bit too short to keep it in view. Although, let's see. I've got this cable, which is actually a switch as well. I don't know. Do you chat? Say yes in the chat if you think I should actually try and load CircuitPython on here. Oh, look at that. Start, jump, shoot. Push left button to continue. Start. 3, 2, 1, go. Oh no! Game over. Can you see that screen? I can't tell. 3, 2, 1. What was jump? There we go. Oh no, I hit the bird. I'm terrible at games. It's interesting that they're shipping with a black and white game on a color screen. Oh yeah, here we go. I'm doing real well now. Interesting. I like tried to short press so I wouldn't go all into that. Okay, so is it Windows 10? I see a yes from Johnny. Yeah, Jim says funny how they use the old school IE logo. Yeah. And Sam says I love the window at the back. Yeah, the window's cool. I like having a case like this. For sure. So let's read the instructions. And we managed to slide it on. To enter the bootloader, slide the switch further away from the on button, which is all the way down. Let it go and slide it again. I don't know. Is it? I don't even know if it's a UF2 bootloader actually. Oh, look at this. They have links to instructions for MicroPython, which if you look in the URL is actually ArduPy. And then there's also Arduino instructions. And like nice diagram. This pamphlet's really neat. It reminds me kind of the packaging from Arduino actually. Okay, so let's see if we can slide it down and slide it down again. I assume that's not the bootloader. Like, am I trying to... Do you think I'm trying to double click with... Yeah, I thought it was down. I don't know when am I going to be in the bootloader. Let's see. What's it say? Slide the switch further away from the on position. Do you think it matters? Because I think I could slide it both up and down. MPP3 says, please load CircuitPython. I'll try. Oh, okay. So if I turn it, if it's all the way off, that's up. Okay, so let's see if I can figure out how to do this. Okay, so it's on. And I think it's a double click. Oh, that looks promising, because now the screen's not on. Victor wants to see me load it too from LinkedIn. Okay, so let's see what happened on here. So the CircuitPy is definitely not this device. So let's pull up. Do I not have a browser window over there? This is gonna be I have other stuff in this box. I don't actually remember what's in this box. Okay, let me switch to this. So I'm gonna go to circuitpython.org/downloads. And I want the Wio terminal. And I'm not actually going to download the 6.0 Alpha 1 because I know that the power on and hold for 3 seconds. Okay, so let me try that. And yeah, if any seed folks are in the chats or want to help me out, we have the WeChat going. So let's see. It doesn't say I did add this note that, like, by the way, the Wi-Fi doesn't work right now. But if you hit this browse the S3, you can actually download the absolute latest version. So, and I guess this is something good to show. So here's all the commits that it's been checked in for. And they're sorted by date. So you can see June 30th is the first one that we have in here. And then we did 6.0 Alpha 1. And this is identical to what the release is. And I'm actually going to download the absolute newest one. And these are UF2s. The blue LED will start to breathe in a way that is different to blinking. Okay. Thank you for reading their wiki. All I see is there's a green... Oh, okay, now you can't see it again. I do actually have this view as well. So I see a green LED through the window, but it also looks like there's an like NeoPixel LED next to the SD card slot here. So let me try the 3 thing. Yeah, Bruce, the thing that you sent me, that's what I was trying to do, is basically a double tap. That's what is in the instructions here. I don't know if you can... Here's the instructions. You can see the diagram is the same. But there's no blue LED that's breathing. So, and does the wiki say that it should be UF2? Let me disconnect that. I've got this like feather sitting there on as well. Let me just see if I can't. Okay, so that green light is just power. Oh, you know what? I think it's that I have it on a, this USB cable is on a switch. So, okay. Now we have data access to it. And we can see an Arduino. Okay. That's promising. And you can't see that because I'm on overhead. So let's go back to the browser. Yes, you have 2. Thank you, MPP3. Okay, so we have an Arduino drive. And so this name here is actually the name of just like the file system that's been formatted. Which is why if you've ever used like the file system stuff after CircuitPython, but with Arduino, it still says CircuitPython. It's because it's actually a matter of like who created the file system. And yep, we can see that there's a current.uf2 and an info uf2 txt as well. So we can just go to our downloads and sort by date, and we can see the Wio terminal file and just drag it over. And switch to the overhead. And look at that. We got a CircuitPython terminal. Da-da-da. So Blink is up in the top left here, and then we can see the hello world code.py. Yeah, got it. It was not the Wio terminal's fault at all. It was my having it plugged into a USB cable that didn't have data turned on. Which I don't do because, well, you know me. Having the data on is bad if your USB code is broken. So cool. That's super awesome. And now we can see the CircuitPy drive, and we can double click into here. And I probably overwrote this other code that I was doing, but that's okay. I can change it here, and if I save it, and I press the wrong button, now we can see that the text changed as well. Fede2 points out that I like that you can change the label for the file system. I'm now playing at the same time with a PyPortal clue, and it's confusing to have CircuitPython everywhere. So yeah, looks really good. I love that. I like how polished it is, really. Um, it's quite neat. So fair warning, Wi-Fi and Bluetooth does not work on this. So don't think that you're going to be able to connect to it right now, but you should be able to add to it because it's a separate coprocessor. It's basically like the ESP32 SPI stuff that we're gonna talk about later. So that's cool. And wow, that was fast. You just proved to the 5-minute experience that is part of the Adafruit. Did I do it in under 5 minutes, even though I had my USB cable set up wrong? I think that would be cool. Double quick tap according to the wiki. Yeah, thank you so much, MP33. MPP3 RCINX. Okay, let's keep going. So actually, the next thing I snagged here is I also ordered the battery back for it. So this is the cover. It says Open Hardware Facilitator. Neat little diagram with an about us. It says Seed Studio develops and brings to market innovative and cost-effective prototyping solutions for hobbyists and aspiring inventors. Since we opened in 2008, we have provided more than 700 unique open source hardware products to over 50,000 makers and inventors all over the world. So super neat. Link to their website and the product. And it's marked Innovate with China, which is neat. And open source hardware. The gear logo. Not the newer one. And it looks like I've got to cut this really awesome sticker to get in here, so I'll do that. Yeah, and it's $30. I did pay like $20 in shipping because I didn't want to wait like weeks. But DHL was actually like even quicker. Mark says open it. I'm working on it. I know so it's got black foam or like anti-static foam, and then just the back here, and it's got like the pass-through header and just more Grove connectors on the side, and it looks like a USB type C as well. This must be to charge the battery on it, which actually makes sense why I wasn't able to turn it on until I plugged it in, because the device itself doesn't have a battery. So hopefully it's okay with me mounting it immediately, and looks like it is. So now we've got kind of them both on there, which is pretty neat. And so maybe if let me eject my drive, be friendly to that, but then I'll plug it out or pull it out, plug into the other one. And I don't think I'll get a drive now. No. I just realized I shouldn't be careful about what's in my home directory. That's all right. All right, so that's the battery back for the Wii terminal, which is really neat too. So I'll probably just leave that charging actually. Let's see what else we have in the box. Yeah, I haven't played around with the M5 stack at all. It's a neat form factor. It's also very reminiscent of the PyPortal, but with a like actual a fancier case. Okay, so next up, what I have here is this Wii Lite W600. Since I was making an order, I figured I'd pick this and another one up. So it's basically, I think, a SAMD 21. It's Feather form factor, although it's not officially branded as such, I don't think. But it's Feather form factor, but it also has the castellations on the side. It's a SAMD 21 with the W600 is the module for the Wi-Fi there, which again, warning, it's not supported by CircuitPython as far as I know. Bruce says, I just checked, my order from March was just shipped. I guess mail was a bad option. I don't know. Like, I did mention it to them that I had ordered it, so there's a possibility that they kind of sped up the sending it to me. But I did pay for DHL to do it. So because I think the ship time for mail is like 21 to 30 days or something. Yeah, so I figured I'd pay a little bit more. So the next thing in my box here is a Wheelite MG126, I think, which is this very similar idea of a feather form factor. Oh, everybody gives you pin headers. So this is just another SAMD21. And I don't think we have CircuitPython builds for this, but that then has, I think it's Wi-Fi. Let's see what it says. But again, fair warning, it's not officially supported by CircuitPython, the board or the Wi-Fi. It says, the Wheelite is a new series aimed at providing cost-effective development platforms for IoT. Wheelite MG126 is using the SAMD21 as a main controller, and the MG126 a very low-cost BLE RF transceiver chip to perform Bluetooth low-energy function. This board is compatible with Arduino ecosystem, which means you can use all the resources existing in the Arduino community. Breadboard friendly. While if you need fast prototyping, we also provide a Grove breakout to bridge this board to 200 plus plug and play Grove modules. So cool. And that's actually a sticker. Johnny says my PyPortal died. How did your PyPortal die? Bruce says now I need to look through my box of seed stuff. Yeah, I mean, theoretically you should be able to run CircuitPython on these 21s, but they're not going to be very fun because they don't have much RAM. And like any support for the coprocessor, the BUE or the Wi-Fi one is going to cause you to just like chew through it real quick. So the SAMD51 is definitely a better option. Oh, great. Bruce says I saw that Greg Davil is prototyping a tiny ESP32S2 board, or at least ordered the boards. I don't really like super small boards. They don't have a lot of pins broken out and stuff, which I guess is some sort of a segue. The last thing that's in the box here is I think it's the Xiao XIAO. And it's interesting that it's in like almost what I would think of as like a peanut or a candy wrapper, but it's marked with seed and just like a sticker for the barcode. 7/4/20. Where do you think that date comes from? That's like 6 days ago. All right, let's open it up. It's interesting to open it like that. So these are stickers, I think. And headers, and then the board itself. So I've been supporting people a little bit. I lurk on the seed forum. Well, I check other non-Adafruit forums once in a while to try to like help with CircuitPython things if they've come up. And there's been a few people asking about support for this. I think it's SAMD21. Oh. Mark says, no, Tanya, they're using the real date order, the 7th of April. Yeah, that makes more sense. Jim and DCD also point out the same thing. And George. What is this? Beauregard says, I have the Wi-Fi version of that SAMD21 seed board. It's a nice board, but yeah, not a lot of storage. Yeah, and the other thing I think that applies to this, the Xiao here as well, and try to correct me if I'm wrong, but I believe that there's no, correct me on the pronunciation, but I, yeah, Steve points it out too, that my date format's wrong. I'm an American, I get it wrong. So that, yeah, this is a SAMD21 based board, but none of these SAMD21 boards have as far as I know, have the external SPI flash that we started shipping. Basically all of our, like from the time we created CircuitPython, we pretty quickly came up with this idea of needing the external SPI flash. So the drive that you see in CircuitPython for an express board, as we call them, is actually on a separate chip. And what that does is that actually gives you a little bit more internal flash room to have more features of CircuitPython built into the board. So the SAMD21 is pretty limited. I would encourage people to not make new boards with the SAMD21 if you can help it. The 51's great. That's a pretty obvious thing to use in place of it. It's nice and small, and it's castellated, which is cool, and there's nothing on the bottom. So I think the idea of having these castellations is a really good one. And yeah. So yeah, the other thing that I've been thinking a lot about, and another Chinese company, Maker Diaries, playing around with, is this idea of using M2 slots for modules. So let me just pull up. Let's close this. Let's just, since we're showing off some other cool boards. Let's just look at a pending PR here. Yeah, everybody else got the date format but me. Oh, that looks kind of like one bitsy. So in the Discord, there's a picture from Bruce of the board that Greg Dabble's designing. I actually have a board on the way from Greg that I was hoping to show off as well, but it hasn't arrived yet. So if you look in pull requests, and let me switch. I remembered. You're probably screaming at me in the chat. So here we have this add two boards for the NRF52840 using an M2 dev kit. So this is from Maker Diary, and Shang Yu. I'm probably butchering it. I'm sorry. Friend of me on WeChat, so it can help them out as well. But these dev kits are pretty interesting. Because they're basically, and I like this idea a lot, they're moving the core microcontroller to an M2 size module, which means that, like, if you are doing what they're doing with the second thing, is they're designing a USB and Bluetooth keyboard running CircuitPython. But I just noticed this. So this is their prototype. And then looking on the, where did I see? I feel like I saw a different picture for it. Where is that other picture? There's a picture of the back of it. Maybe they made a separate CircuitPython.org pull request. No. Where did I see the other picture of it? But basically, they're using the module on the keyboard as well, which is really quite neat. Oh, I think it's here. So you can pre-order it if you're interested, and then they kind of tell you about it. Oh yeah, and then this inset is really neat. So if you want to swap the controller on the keyboard, you don't have to remake the whole keyboard. You just switch the M2 on the back, which is a great idea. Clear Signal in YouTube asks, why should someone use Python instead of C on microcontrollers? And I think the first answer I have for that is it's much faster to iterate and code in Python. It's not saying, I'm not making the argument that the code runs faster itself, but it's faster to program Python by a wide margin, in my opinion. One of the reasons is that there's a couple of reasons for that. One is that the actual flash cycle is much quicker because you don't have to erase the entire chip and reflash it every time. You're just changing the file system and everything else is the same. And then the other thing is that like because Python's higher level, you just straight up have to write less code, so it goes faster that way as well. Yeah, so this is really neat. The removable M2 modules is an idea I've been meaning to do and kick around. I think it's a great idea, and I'd be curious to see what the pinout is that they settled on for that. But yeah, looks really neat, and they're a small startup company that's obviously making some pretty neat stuff. So happy to see all these different boards come in. And yeah, good morning to Unexpected Maker. No worries that you're late. You just missed me going through a Seed Studio order that I got in the mail. Yeah. And the other thing about Python in these cases is that it's pretty easy to add C to it where you need the speed of C. You have to rebuild the whole thing yourself, and you don't get that iteration stuff. But there is always this, like, if you find out that you actually need C for something, you can do it. You can use it if you need it. So yeah, any questions? I think that's all of the show and tell portion of it. I'll leave that there, although you can't see it. Let me just consolidate these boxes a bit. Yeah, I think the ESP32S2 is just going to be a super popular option for people. Hi, Grogard. Thanks for hopping in. Beauregard asks, is there a standard pinout for using M2 like this? I might be concerned about end user confusion. I don't think so. In my looking, there's actually the M2. Let's pull up the Wikipedia page. When I've been looking at the M2 form factor, I've kind of thought that there's another name for it too. There's actually different keying patterns. So there's actually different like notch locations in the that are like physically on the board and the connector there. And you could see that like based on the different key IDs, you get different notch pins and then different uses for things. They might be targeting like the actual like standard pinout for here, right? Because like if you do a key ID E and you do PCIe, like PCIe you wouldn't do, but you'd be able to do USB and SDIO and that stuff. Like you might go that way. I think the approach I was thinking is that I would like make sure that the power pins weren't messed up, but then do the other thing that they standardize on, I think, is like the length of the module, I think, because you have to screw the other end down just for like mechanical stability. And I think kind of what I was thinking is that if I were to design the modules, they would be like a weird length, so that if you tried to put them down on a motherboard, they wouldn't like fit. But I also wanted to pick like a notch that wasn't like totally obscure and super expensive, because part of the reason I like this idea is like I like the idea of modularity, but modularity can be really expensive if you have to put high density connectors on both sides. So with this, you can just put a high density connector on one side, and then the board itself is just kind of like a regular PCB. But yeah, I'd love to see a standard M2 format, and I've like played around with what it would be for my stuff, but I don't know what their pinout for the Maker Diary stuff is, but I assume that they're going to do some like standard pinout stuff there as well. The other kind of like, if we're talking modular, the other kind of neat system for like surface mount stuff is this micro Like they've got some pretty wild module sorts of stuff. So they like have this click standard that is like actually on a lot of like vendor provided dev boards. And then there's also this what is the other one? Mcu Cards. So this is like their other system, which is pretty wild. So like it's two high density connectors with the like bare minimum like decoupling caps and stuff on the next to it, which is kind of a neat system as well. Because I like, especially when I was doing this keyboard stuff, it's like you pay a pretty penny for like a large PCB, and like, right, the one that I made, I like basically cut the holes on a feather to make them castellated. But like I can't easily upgrade that to like a new MCU like the NR52A40 now. Bruce says the M2E key, they say. GrowGuard's been experimenting with modules for a while too. Ah. Bruce says, I never liked their usage of their own C compiler and libraries, but Micro does have some nice stuff, true. Yeah, I don't know if they, I have never used their like ecosystem at all. But, you know, thinking about like, how do I swap like the brains in and out without redoing the whole board is kind of a neat thing. Okay. So that's that. Anybody else have neat stuff that is worth looking at before I move on? I think the next thing I want to talk about is I want to go over kind of where I settled on the ESP32 and networking SPI APIs. On Discord, Mark's posted his own Narwo boards, which is a similar idea. Yeah, GrowGuard says, I always end up coming back to the castellated edges for cost reasons. But it means that it's not removable. Yeah. That's why I ended up with the M2 ones, is that like they're super... Like the challenge for cost is you have to find the thing that everybody uses that's readily available and low cost. It's really hard to beat pin headers in terms of cost because they're like, I mean, they're kind of large, but they're mechanically and electrically really good, and they're cheap. All right, let's talk. If somebody distracts me, we'll get distracted. But so yeah, that's pending. I just had some feedback about like their status LEDs, and should be a help. Mark says on his board the pins are 1.27 millimeter. So they're half the distance than the ones on like the Wii terminal here. Okay, cool. UF2 is awesome. Yeah, so let's talk through. Let's see, what am I showing? Okay, I'm showing my screen. And I think I have the stuff I want to do, except can I don't have enough room for it to be split. So great. Okay, so last week we started working on making ESP32 SPI library a lot more concise. And so let's just start by looking at where I'm at with that. So further background is that I'm actively, well, my end goal is to add Wi-Fi support to the ESP32S2, which most of these streams have been like me working on bits and pieces of that. But this week was a bit of a detour, and probably some of the next week will be a detour as well, because I wasn't a huge fan of like so kind of the history of networking in a nutshell. The history of networking in MicroPython, like they have some native stuff. And actually I was talking with Brent this week, and he pointed out all of the PyCom stuff as well. Like they kind of take this approach of like being more like CPython, where networking is there and present, and like managed for you externally. So like in CPython, you don't really say like connect to this Wi-Fi access point, because you just get a socket and you can talk to the network. And I think that's the like kind of more the approach of that MicroPython took and what PyCom took with their version of MicroPython. And we kind of initially did that. We contracted with somebody to like add the like to get the WizNet support back into CircuitPython. WizNet is like an external chip that does Ethernet. And so we had like some native networking APIs, but we weren't huge fans of it because it's in some ways it's like hard to maintain stuff that's on that's like built in if it's going to change or it's like complicated. So we kind of went this other route of having like Python level coprocessor stuff. If you've seen like the PyPortal, they have like ESP32 next to the SAMD51 that manages all the Wi-Fi for you, and that has a lot of advantages. One advantage is that like straight up you don't have to share resources with any of the networking stack, which is really nice, and you don't have to share time either. So like it can go off and do whatever it needs, and it has all the access to the CPU that it needs. So that's the model that like kind of we're at right now, and I think with CircuitPython going forwards, I want us to move to more of a model like that, where actually our main use case is where an external chip is providing us network access. Because since we did the ESP32 SPI stuff, we also like Brent also added APIs for like internet access over cell network stuff, and I think maybe like LoRa as well. So like rather than having CircuitPython need to know about all those different ways to connecting to the network and making it kind of native thing, instead what we're doing is we're moving to a model, and I want to move to a model where like the APIs are designed where like we kind of assume that it's done in Python, and so the ESP32S2 will implement the same APIs and not kind of rely on the special privileges of being native. So I wanted to take a fresh look at the ESP32 SPI library, which is, I think, the most popular kind of coprocessor, and just reevaluate the APIs before I brought those APIs to native CircuitPython. And so that's where we left off last week. That's background for folks. Charles has a question in the YouTube chat saying ESP32 SPI is an AT command set API. That is not the case. The ESP32 SPI, the way that it works is that there's a command set. I don't think it's AT. I haven't seen any ATs anywhere. It's done over SPI, which I think AT is usually over UART. And then the coprocessor code is actually just an Arduino sketch. It's an Arduino sketch where you just get like some command and you run some Arduino code for it. So I don't think it's actually a proper AT command set. Okay, so last week we were looking at this file, the core ESP32 SPI file, and trying to like talk over all the different bits. So let's see where we're at with that. Is that okay with everyone? Okay, so we have this big long list of what about WizNet W5500? Is that the recommended option for Ethernet controller compatible with CP? Yeah, I think it is. And in fact, we actually have a Python level driver for it now as well that we'll want to update with these API changes, but you shouldn't need the native stuff at all for it anyway. But yeah, I don't know exactly what the WizNet chip is, so check the library, but I think that is the recommendation. Anecdata says yes, but be aware there's no TLS. That's a good heads up. Okay, so there's a big long list of constants, and the thing to be aware of, we were talking about this last week, I think, where you had to have the underscore and you had to have the const. But I was looking at the memory usage more this week, and I think it's actually a little bit even further that you have to build it as an MPY file. I don't think that with const, if you're importing the PY file, I don't think it does that optimization for const. So in general, I would encourage people to only use const where you know it's actually going to help you, because there are a couple other cases where I've seen const where it's definitely not going to help you at all. It just makes it a little bit more confusing. Because const is definitely not a Pythonism. It's a MicroPythonism that is optimizing variables away. The nice thing is that you can still be backwards compatible, but if you just, like in CPython, you import const as like a lambda that just returns the value. So it's not hard to undo. So first and foremost, I have a new network class, and this is a wrapper around the scanning code for finding out all the Wi-Fi access points. And the reason that I wanted to do this is the original way that the Wi-Fi scanning stuff worked is that it was creating a list of dictionary objects with like 4 keys for like basically all these things, and they would always fetch them. Whereas I wanted to optimize a bit where I create a network class, you get the SSID and the index, but then all the other stuff you only fetch when you actually want it, which will just reduce the amount of SPI traffic we're doing and also the number of allocations we're doing. Because remember that when you construct a network object, you're basically making an object, and all of the code in these functions is shared across all instances of that. That's why they take this self in, which is like the differences between the stuff. David, I don't know anything with TLS. I don't know my Ethernets. So sorry, I can't answer that question. Maybe Anecdata can. Okay, so that's just kind of like a network class for results from a Wi-Fi scan. This is pretty much the same, I think. The constructor for ESP32. I think I changed the name. It used to be like ESP32 SPI controller. So I've simplified it to just saying ESP32, and it just takes all the pins in. Reset's the same. Wait for ready is the same. Send command is the same as well. I'm picking over whether I want to do it this way, but I haven't decided yet. It feels to me that it's a little complicated because it's doing parameter packing, and it needs to know if the length of the parameters are 16 bits or not, which is a little weird to me as well. But I haven't kind of like been able to figure out exactly what I want to do with that. There's some simple read stuff and a write stuff out as well. And then there's a send command response, get response, which is kind of like the thing that most of the other APIs use. So for example, like to get the status, it does this send command get response with just a different code. So we still have status, which I think makes a lot of sense. You want to know the status of the coprocessor, and maybe these status values we actually need to standardize, which I think we probably do want to do. Firmware version, MAC address. So MAC address would be the like sort of standard thing. And then I renamed the scan network thing. I don't remember what it was originally. But I modeled it after the way that the scanning works on the BLE APIs, which instead of returning a list, now we're actually yielding each result, which in some cases will mean that you can actually scan a lot faster and decide that you found what you want faster. So it's now start scanning networks. It starts the scan, which is actually like a time limited thing. We try to get the results, and then once we get the results, we yield each one of the results, which means that we may not actually get through the whole list if somebody starts. So we also call stop scanning networks as well. And this is just a helper. It's now underscore, so nobody else calls it. And instead of, for enterprise connections, there used to be like 5 different set commands that you had to call for like setting your username, your password, your anonymous identity sort of stuff. And I've merged that all together. So now we have just a connect method that takes an SSID and a password and a timeout. And I moved the commands into there, except for the one that's shared. And then I also now added this connect to enterprise, which is like bundles all the stuff up you need to do to connect to an enterprise level Wi-Fi access point. So it now takes like, you can't see everything. It takes SSID, username, password, identity, and timeout. And it kind of puts all those sets together rather than them being separate. The way that you can tell you're on Wi-Fi is through these 4 properties of SSID, BSSID, RSSI, and IP address. For the access point, you have this access point active property. And to start it, you can call start access point, which I have not tested, so it may not be right. One thing that was a bit of a challenge was this ping. Ping is really useful for diagnostics. And so I wanted to leave this in there because it's always like kind of one of those first things of like, do you know it's working? So like ping's good to have in there. And one of the things, I tried to move this get host by name, which was spelled differently. I tried to move it to out of this class, but it turned out I actually needed it for ping. So I made it private, but the other place that I moved it to, which I'll show you in a second, it calls it as well. And then the last thing here, so this file's now 564 lines, not 900 something. And that's mostly because of, well, there's a lot of constants at the top that we may be able to just delete, which I'll deal with later. And then I just have debug. David G in the chat asks, you use time.monotonic. Should you use time.monotonic milliseconds? I don't really care. It's just for a timeout. So like any precision that we lose, I'm not too worried about. And monotonic, well, I'm not sure. Floats. So regular monotonic is going to give you a float. And that is, I'm trying to remember if it's allocated on the heap or not. But if you do monotonic nanoseconds, it can, if it gets large, it can be allocated on the heap. So you trigger an allocation with it. So yeah, I think it's fine because we're not trying to be precise with it. But maybe we'll find a reason later to change it. Anecdata. Hi, Mr. Certainly. Thanks for jumping in. Hi to Jeremiah as well. Anecdata asks, should get host by name and similar methods be separate class or DNS type stuff? So, one of the challenges that I was thinking about last week and that I've kind of settled on is this idea of how do you basically like connect this custom stuff, like getting on the Wi-Fi stuff that's not in CPython, to an API or multiple APIs that are like CPython compatible. And so I've created this notion of a socket pool, which you can use in place of the socket module. So if we look at socket pool, it's a class, it's not a module, and you have to construct it within the ESP object. And the advantage of being a class instead of being a module is that you can actually have multiple of these. I need to change it actually so you can't be multiple of these with the same ESP object, but you could actually theoretically have like 2 ESP coprocessors and manage them separately. So I wanted it to be an object because we might actually have multiple of them. And then the API in here is actually straight up CPython socket APIs. So to get code that's both CPython compatible and CircuitPython compatible, you construct a socket pool and then just treat it like the socket module on CPython. So it's got normal socket, which I moved this get socket command into, which is basically going to tell us like if we run out of resources on the coprocessor before we actually create a socket object, which I've now also not called lowercase socket because it doesn't matter what the class is called. And this is actually where get host by name lives in CPython land. So that's where I put it. And you can see that it's actually just calling out to the ESP's version of that. And that's similar to get address info as well. And those are two APIs that are CPython APIs. So to answer Anecdata's question, I just put them where CPython has them. I wouldn't go further than that. I think it's okay to just match it up. So I've copied a lot of the implementation of things out of that ESP file to here just as a temporary thing. And I need to do this more work on it. But so here's my socket and I'm doing some validation. So that the socket pool figures out the socket number. So I know that here. And by default, we're doing TCP mode. And then I added connect, which is a standard socket API, trying to get that going. Some of this like send, write, read line are all old, and I think I just need to delete them, but I'm not there yet. Receive, I have to check. Like I have to compare this API against the socket API. But I think that I want to get rid of any API like receive where it's doing an allocation. So like it's doing this buffer plus equals thing. And then at the end, it's doing like an allocation here. Thanks, Mark. Sleep well. I know it's late in Europe. Have a good night. So I want to replace any sort of receive function in here with a receive into or whatever. Like socket has versions where you provide the buffer. So those are the ones that I want to have in this new version because I want to try to kind of put those guardrails that CircuitPython's pretty good about being like, really, you shouldn't allocate more stuff. You should provide the memory and think about it at like the higher level. So yeah, I've moved this stuff over. I haven't tested it all. And let's just see what else I've got here. Open. So SSL becomes a little weird. The way that SSL works in CPython is that you wrap a socket with a context. Which is actually a really good thing. So there was two APIs on this ESP32 that set certificates, and now that's done via this SSL context instead, where you can give it two certificates to use for the TLS connections, and that actually applies to like the ESP32, like Nina firmware is not like good about segmenting that off, so it will actually apply to every socket on that ESP later, but that's fine. I'll just fake it. You use it the same way, you most of the time will get the same result. And there's also this create default context, so that's been moved. It's also not tested, so it's going to change. Hi, Spectre. And then I think the last thing to cover in terms of just recap is this is not right. This is not the version I want. There we go. I Control-Z'd and got the version I wanted. It gets a little funny because I actually do, when I'm working on these libraries, I'm actually editing the code, like the CircuitPython drive version. So I try to remember to like save it back to my hard drive before I'm done. But I also just kind of leave them in my browser or in my editor like this as a backup. So the other thing I had to do is refine the requests library. Johnny says untested code for the win. Yeah, I don't know how I'm gonna test the enterprise level Wi-Fi stuff. So if any of you watching now or watching later have access or use a Wi-Fi access point with enterprise, let me know. And I'd love to. I'd love to have you help me test. Fede2 asks, do you normally write unit testing into a rewrite like this? No. This is one of the things that like we're pretty bad about. Like in general with the code that we write at Adafruit, at least the like driver stuff, we don't really unit test. We do manual testing kind of only. But if you're interested in adding unit tests, I think we should. Fede2 also has enterprise stuff. Awesome. Yeah, so basically we ask people to test it and help out, and we fix it once we find things. But I think that as our code base grows and matures and is used by more people, I think we'll see more testing stuff. Summersoft, who's in the chat occasionally, is doing some pretty interesting work about like testing stuff on device, which is one thing that we definitely need to do and is not easy to do either. So if you're interested in testing, unit testing, please let us know. It's something we'd like to do, but it's just not something we've done historically. Okay, let's go through here. So as you saw, I deleted the set socket thing that was here, and we have the standard response, which I think is basically the same. You can see the read to stuff that I added 2 weeks ago now. I think it's 2 weeks. It's definitely a little chunky in terms of how much logic it is, but yeah. So I've moved all of the. Fede2 asks, what would be a nice simple place to start adding unit testing? You tell me. I mean, like, luckily with a lot of the new APIs that we have for drivers and stuff, like it's pretty easy to actually, like they always take in the interfaces that they use underneath usually. For example, like if you have an I2C driver, like there's usually just an I2C bus that you pass in, and you could totally mock that out with something that just returns the right stuff. That's one way. We do actually, like MicroPython has really great testing for the core VM stuff, and we make sure that we don't break any of that. I'll update that stuff if I ever do change like core Python stuff. Yeah. But I would love to actually, and for the core unit testing wise, I would love to actually see C level tests. Not even go do the round trip in Python. I'd like to, like, especially when I was doing a lot of the logic for display IO, like it would be really good to have unit tests for that, because it's like hardware agnostic, but it's still a lot of logic. But yeah, yeah. Unit testing takes time. It also saves time in the long run. But a lot of like the way that Adafruit's operated in the past, I think, is like much of the code that you write and manually test doesn't really change over time. And so I think that's one of the reasons. Like if you create a BNO55 like device driver, like it doesn't change that often. It rarely changes. So the unit testing is not that critical. But yeah, we should. Testing is always better. Okay, so I'm introducing this session class into the requests, and this is actually something that regular requests has as well. Yeah, Grogard says, good software takes forever and is hard. Yeah, totally. I was reading, I'm on the Zephyr TSC Technical Steering Committee, and they actually, I'm going to get distracted here briefly and plug. If I can remember what it was. I think it's memfault. Yeah, interrupt memfault blog. So I hadn't seen this blog before, but they actually have really good, all sorts of different topics. And there was at the turn of the year they had like a person talking about like embedded in 2020. Yeah, beyond firmware in the 2020s, and really talking like spoilers, but basically it's going to be more and more of a software world. My guess is that hardware businesses will not only do more software engineering, but look a lot more like software businesses. Dylan Rice says, if creating mock inputs for unit testing is easy, then I'd say it's worth the trouble. But that can be a big if. Yeah. Hi, Arnold. Grogard says, I've been working on the giant board stuff for almost 2 years at this point, and it still needs work and could be better. Yeah. I mean, CircuitPython's going to be 4. Kind of like, I started working with Adafruit in August sometime of 2016, so like CircuitPython will be 4 soon. And there's always more work to do. But yeah, I think software is going to be more and more important. And this blog is awesome, so I'll just there's some really cool stuff. They were talking also about like this thing that visualizes like where code size happens, and so I was looking at that as well. Just drop this link in the chats. Oh, come on. So yeah, we got about 45 minutes left, and there's 2 things I wanted to offer up that I could work on. I've kind of covered like what the work I've done with ESP32 SPI is, and I have a Metro M4 Airlift Lite that I'm trying to get the simple test working, but it's actually not working, and it's pretty, I'm not quite sure. Like I'm trying to connect to the Adafruit test server, and like that's not working, so I'm kind of like not quite sure how to debug it. So I also do have like a Feather M4 with the old stuff that I was going to compare to. So debugging that is one option. The other thing that we could do in the next 45 minutes is actually start to sketch out the like shared bindings layer of the Wi-Fi APIs, and actually probably turn off the existing ones as well. So do you want to see me do C code debugging or stuff, or do you want to see me doing the debugging of the Python side? And there's a couple questions while you get to the chat, so tell me which one is more interesting. Grogard says, I've been shifting a lot more towards software. The main idea now is to make hardware you know how to set up and consult to your customers. Yeah, the hardware is not the hard part. I mean, manufacturing and producing hardware is hard, but the design of it is actually not that difficult for the class of stuff that I work on. Like Lamore Ladiata had like this design for the tiny logic friend, and it's just like, she's like, do you want me to assemble this? And I'm like, yeah, sure, but like it's not like, it's a software problem. I just don't have the cycles to like finish the software to make this like really easy, low cost, low performant logic analyzer that everybody could use. Like I just don't have the focus or the time. Fede2 also asks, is this socket pool more efficient in memory? The answer is I think it's about this going to be the same efficiency as the current implementation. But a related thing that I want to do is I want to make the JSON native library support parsing JSON out of any object that allows you to just read into a buffer. Whereas right now the ESP32, like if we look at requests, even here, I think we do it. the request's response object has it has this JSON thing, and when it, oh, I changed it already, but the current version has a load S, so it makes it a giant string and then parses it. So I want to make it so that you can just provide anything where you can read piecemeal stuff, and we'll actually be able to parse straight into JSON rather than having a giant string in between. I definitely want to do that work as well. Anecdata asks, is UDP implementation largely the same? Parentheses, it's kludgy due to Nina implementation. My plan is to change it because from what I could tell, it's not done in a way that CPython does UDP. So I'm planning on changing it to model just after an example that I pulled up for how you would do it with CPython. So yeah, it will change, but the Nina side won't change. Grogard says, yeah, PCB design is like a one-time thing. The software is always changing. DCD says either path is fine. David says, do you sniff, let's say on the Ethernet side, the traffic you generate to debug your code? I haven't yet, but I think that's one option. I was talking to Brent about how to test UDP, and he said just use netcat. So that's kind of that level. On YouTube, Unexpected Maker says, let's not talk about hardware manufacturing. Haha. Yeah. I do not envy people that get into hardware manufacturing. And Unexpected Maker also says, I got into hardware so I could get away from software. I'm a sucker. Yeah. Yeah, I like software. It's easy to iterate. There's a lot you can do in software. But I like this world. I like this world of hardware and software. I like software on something you touch, not just in some cloud. I did enough of that. Okay, so I think I might actually do option C. Because we've got like 40 minutes, which is not a ton of time. But with Anecdata or... yeah, Fede2 talking about needing to do the JSON work. I actually kind of want to look at the JSON thing. Because I think that is like a pretty segmented sort of... I'm sorry for the beeping. You know how it goes. Like they didn't do this until like an hour before I started streaming. Right. Charles points out UDP does not check for missing packets, among other things. And Grogard says, waiting 2 weeks for iterations on a PCB is lame. Yeah, that's why I tend to do like multiple PCBs at once. Once I'm done with one, I just do another until the other one gets back. Alvaro says on YouTube, great to hear about the workaround of the step skipping. Oh yeah. Awesome. Okay, I want to do the JSON thing. Is that okay with folks? So let's see if we can't get our JSON stuff more memory efficient. So I'm gonna fetch. Hopefully they're not gonna take too long. They're like working on the driveway for the place across the street. And so basically when I'm starting something new, I would recommend this for everybody. Always start on the latest, and the way that I do that is I just check out. We switched to master or main from master, so I just check out. So I fetched, and now I check out Adafruit main, and it will tell me that like, oh, you're on this weirdo thing, and get status is by far the thing that you should always do. Unexpected Maker says, yay JSON. Yeah. Oh, and Fede2 says, I was actually looking out the window for a truck. I'm sorry. The truck is here. Is it possible to do low-level things like Scapy when using a coprocessor and high-level API like this? I don't know what Scapy does. Could you point me to something about that? Okay, so I've checked out the newest main, and now I'm doing, they just added switch. So I'm improve JSON. Actually, it may just work. It may just be that we were using it wrong, but let's take a look at it. And then let's also update our submodules. And let me plug in. I think I'm gonna use, I have two boards. I have this Feather and I have a Metro Airlift. I think I'm gonna use the Metro Airlift because that's the one that's got all my like in progress code. Which I guess I wanted the other one as a, oh man, Sublime just crashed. That is the first time I've seen that. I was like, why can I see my desktop now? Ah, packet crafting. All right, now you can see all the different windows I have open. There's the ESP IDF one, the election calendar stuff. And this is the one we want. Let's see, what is this one? This one is CircuitPython. We might actually want this one as well. Actually, that's the one we want. Okay. Packet forging and sniffing in Python. I don't think that I don't think this is the right API for that. I mean, I'd be curious to see what API under the hood they're using from Python. I suspect that the bottleneck with the way that we're doing it right now would actually be the Nina firmware that is running like the Wi-Fi side. Like, I don't think it's the commands that it provides are not that low level from what I've seen. Okay, so I have this board plugged in, and I'm gonna just take this code.py. This is like the simple test that is like trying to connect to the website and pull it down. I'm actually just gonna rename that away from code.py because I just want to do JSON straight up. Like, I just want to kind of mock it out and reduce the amount of code.py I'm doing for testing that. So this is full like requests test. I always name that something like that. And then we're gonna do a new file, and let me start a terminal so that we can see that as well. So not used to having such a tiny screen. Okay, that looks about right. And then let's file save as this to code.py. And make sure it's working. Which it is. So we're gonna import JSON, and we can do JSON.loadS, and we can just do something super basic like an object. Rob Robin says the Google Data API can give you lots of your YouTube in JSON. Yeah. Yeah, the challenge is parsing it all, fitting it in memory. Because like so many JSON APIs are just like, oh, we're going down to a desktop, and like you spent 50 megabytes just installing Chrome, therefore you can have like a 50 meg or multi-meg JSON file. Yeah. So what I want to see what I can do is I want to be able to wrap this string in an object like, I don't know, we'll just call it buffer. And let's give it the string that it is. And So this is meant to mimic like the way that requests would work. So we'll just say self data equals data, and let's also keep track of where in the file we are, and then just have a def. I think it's just read into, right? Like the stream API, and that gives us a byte array. And so what we want is, now we want to say the buffer is equal to, and then like not decode it. I don't know if it needs to be decoded or not. So let's just do it like that and see if we can't handle that just to load. I suspect, I mean, hopefully it won't crash. So let's see. The way that this would work is buff is equal to self.data of self.i to self.i. Let's say ends, because I know that we're gonna have to think about like end is equal to self.i plus the length of buffer. But we don't want to read off the end, right? So end is equal to the minimum of end, or the length of the data. I think, right? Self data. And we also then also want to say into this buffer. I'm making terrible variable name choices, but it's gonna be the minimum of the two, right? So it's the length of buffer or the length of self data minus I, which is actually remaining. And this is self underscore I. And remaining. This would be remaining as well. Or no, that's index. And then I meant your YouTube data in JSON. Yeah, I don't need a load of JSON. I don't think I need to test it. I don't need to stress test it yet. It'll be interesting though, because actually another thing I was thinking about doing, and I think I mentioned this in the stream before, was adding a new module into native CircuitPython that would track memory size allocation. So for every bin, it would count how many allocations since the last time you like cleared it. So you'd be able to say like, for this section of code, how many allocations did I do? And I think that would be really interesting when doing like JSON parsing. Trying to like do a lot of small allocations rather than any large ones. Plus L. Okay. And then we actually do return the number of things we read instead. So it says OS error stream operation not supported. But it would be so nice, right? Because that would mean that we wouldn't have to read everything in. We don't have to load it all into a whole string. So let's do some digging into CircuitPython and see if we can't find this. And I'm just going to create a new... Oh, I made a new window and I wanted a new tab. New tab. New repos, CircuitPython. And when I want to find something, I use the silver searcher. AG. And I'm just gonna look for this and figure out like where we ended up. I think this might end up being kind of like, I'm gonna implement like a generic stream, and once I implement a generic stream, it actually might end up more places. So let's pull up PyStream here. Not CircuitPython.org. But yeah, wouldn't it be cool if you could hand, like, if it had read into, then we could treat it as a readable stream. 95. Right, so this is using, oh, you can't see it. This is so, there we go. That's a little bit better. So this is like getting the stream. Get stream raise, np proto get npq string protocol stream. So this is the object you're handing in, and this is a way to like figure out whether that object has an implementation of stream. And then if it's null, or any of these things is null, then it doesn't work. But like, I would like it to be a stream that doesn't have like, I don't need a write. Like, I'll control maybe, because you might want to seek. But even then, like, it would be nice if we didn't need it. DCD says, I had often used ACK, but switched to AG after observing Scott's use of it, and 80% AG now. Thanks. Yeah, I fall back to grep occasionally, because AG tries to ignore git ignore stuff sometimes. Okay, so this might be trickier than I was hoping. I was confusing it with the buffer APIs, which allow you to say like, I would need a readable or writable buffer, whereas it looks like stream is like wanting all or nothing. Oh, I guess like np stream op is then also checking. So if we get stream raise with flags that's only read, then we'd be okay. So let's take a look at mod JSON, which I think it's either here or ext mod is where MicroPython puts shared modules. So let's look in here. So if you're doing dump, it's getting stream op right. If you're getting, I want to reorganize this too. So if you're doing a load, it's getting a stream with np stream op read. So I think it would be cool if an object, any object has read into, then np stream op read should work, which I think would be super cool. So the question is how do we do that? One of the challenges is that we have to allocate the stream pointer stuff somewhere. And that could be a little weird. So like, we're basically changing the way that we construct an object instance to like, if the object instance has read into, then we treat it like this. Is that too much magic? Let's see. Let's pull up CircuitPython or regular Python. Python 3 stream. Like, does Python do that? The text stream API is described in the detach, read, read line, seek. That's so crazy to me that like these APIs don't have read into. Like I could have sworn I seen read into elsewhere. Actually, that's a great. Let's just try this on CPython and see what happens. It may not work, which is gonna be a little unfortunate as well. So let's just take this and do file save as, just like something in CircuitPython. Sure. So we're here, and now we can see that there's a code.py. And let's just try, let's see what happens. Ah, interesting. So it's expecting to see read. Which again is unfortunate. But I mean, we could provide read. It's just like providing read sucks because you're doing allocations. But let's just modify this and just humor it. Def read. I think it gives you the length, so let's just print L. See what happens. So yeah, this is an interesting like. Oh. See what it's doing? It's calling load S directly from FP read. So like CPython's version of JSON just reads the whole file and then parses it. Which is unfortunate. Which I think is why it's like okay if we like if the response on if we supported read on our version of requests, like we could make this work. Equals 0. I think that's what it is. Like this should work. We could finish that too if we wanted. I'm so used to it auto running. Did you notice that? It was brief, but I'm like, why didn't it re-pop up? Yeah, so it does work there. Fetty2 says, that's a good problem to have. What happens when CircuitPython does something cooler than CPython? Yeah, it's kind of silly that CPython's JSON parser works that way, right? That it has to just produce the whole string. To me, it's a perfect example of just CPython itself is designed for like a grown into how big of devices you have, which CircuitPython's totally going to do too, right? Like we had all that discussion about SAMD21 earlier. Like we're just resetting where we're growing from. Okay, so let's just make it work. Or at least let's take a look more at the way that JSON is doing it. So if we look at load, it's doing, okay, here's our stream T. And, oh, you know what we could do is we could actually just not, if this is null, although this is get stream raise. Ask Patrick says, looks like people recommend iJSON for that approach. Yeah, but see, I'm not looking for the result to be an iterator. I just want them to not take a giant string at the start. Like I want lots of small allocations, not one giant one. Charles says, what about malformed JSON doc? Yeah, I don't want to worry about that. I mean, that should be handled by this load thing. So if we go down here and let's just find where so it's doing S next, and that must be a stream thing. No, it's not. It's this UJSON stream next. So it's calling read, which is just returning a single no, it's calling read, but giving it a buffer to read into and a length. So this is like basically a read into. Okay, so I think what we need to do is we need to say there's this np get stream raise, and let me just, this throws me off, but like if it's italics here, it'll go away when you open it, or when you open something else. So let's first not raise an error. So let's find the version, if there is a version that doesn't raise an error. So there's a get stream raise. But it doesn't do anything. I don't see a non-raise version. So let's cheat and just snag this. We'll just do it ourselves. And if there happens to be anything here, then we'll do it. So this self-in is going to be stream object. And here we can say if stream p equals null. Do something. Otherwise, do this thing that we already did. And we'll just straight up call it again. And we're going to want to declare this because we're going to want to set this. I think that's right. Okay, so now we're doing the same thing unless it's null, which should be the case that we're in. And we can actually just do, you know, I might want to set up my J-Link, but translate not a stream. Or actually, I don't need to raise an error. Actually, I should probably raise an error. I'm thinking I could also just do like a regular print, but I don't want to continue doing this stuff because it won't work. It'll just go off into the weeds. All right, we're running out of time. My J-Link isn't actually set up, but it's probably not too bad to set up. If I know where it is. It's been so long. It's certainly around here somewhere. Yep, there it is. I have like, it's not even a proper like, oh, maybe let me show this. So I still have this, I'm not using it. In fact, I think I will unplug it. And it turned off, even though it's, oh, it started over again after it got, and now it says hello seed Wio terminal. Awesome. Okay, turn that off. So I've got my J-Link here, and I'm just gonna plug it into my USB. So I'm doing this because I don't want to have to load the code over I don't want to have to load the code over USB UF2 every time. So let me actually, before I think attaching the J-Link is going to cause it to reset. So let me just everything a little bit happier with me that I've disconnected first. Turn off USB, and now I'm gonna plug the J-Link in, and I'll just do it here. No reset, no GUI. Oh man, it's been so long. Right, because I've been doing all of that, been doing so much ESP work, it's been so long that I've used J-Link. Okay, so that's connected. And then now in this directory we're in @mlsamd, we'll do arm. If anybody using the Espressif stuff knows how to do a similar workflow to the thing I'm doing right now, please let me know, because I would love to get away from loading it straight away. So this will reload, it'll rebuild it and load it up. And okay. Because this, I think this is a problem because it's an initializer. So let's, can you see that? No, you can't. Okay, let me switch. So I got a compilation error, which is not surprising. So we're gonna do 0, 0, 0, 0, and then actually let's see what the definition of this is. It's in here, yeah. So there's a stream object and then read. Perfect. This is perfect, because basically what we'll want to do is we'll want to give it our instance object and then the thing that knows how to call back into Python to get data. Okay, and then this is, and we can't do it this way, I don't think. So we have to say stream object equals that. And s.read. This is good. I think I might end up going over time a little bit because I think we could get this working. I don't think it's going to be super bad. Yeah. So let's see if that works. So basically, what we should do is we should get to that if branch where it's null. And then once we get there, we can add our, yeah, actually we should get right here. And in fact, I like to do this. So this is the way you can do an assembly instruction to do a breakpoint. So because I'm off USB, but my code.py is set up to do that like simple test where it was throwing the exception. Like now I can iterate on the C side without having like USB connected or anything. Which should be good. But I won't actually know that it hits this error until I reload it. So actually just let me reload it again. And if my audio stutters, I'm sorry, or like gets out of sync, I'm sorry, but it's probably because I'm OBSing and compiling on the same CPU. But at least I'm small in the corner and you can't see that. But yeah, I think this is pretty doable. Because it takes these two things, it takes stream object and read, and then it calls that read function and gives it the stream object that we wanted. It gives it a place for the value and a place for the error code to go, which are the other two spots. And this is definitely not encoded because Unicode won't fit in a byte. So, okay, so let's just run it and we should hit that assembly spot. That breakpoint. Oh no. Tigerbite says, oh, don't worry, it's been out of sync for a while. Yeah, sorry about the... sorry about the out of sync audio. I haven't shown my face large too long. I really should try with my gaming machine because it has more grunt. I should do that. Yeah. I should switch over and see. Mr. certainly says it's not too bad. Okay, great. So here we hit exactly that breakpoint that I just added. So, you know, our check is correct. So now the thing that we need to do is we need to check if the object that we're dealing with, actually we want to check the type probably. And the native type is going to be obj instance. So how do we do that? What is an example where we do this sort of thing? I'm trying to think of an example where we call back into Python. Oh, I know one. PixelBuff does it. PixelBuff does it because the transmit function for like how to spit the pixels back out is actually in Python. So where does it do that? I think that's what this show does. Yeah, it does this load method. Okay, so we're gonna have to do something like this. The audio video is in sync for me too, but sometimes the subtitles come in before you say them. Is that automatic subtitles from YouTube? That's pretty wild. Is it pretty good? Okay, so here, what are we gonna want to do? So we're gonna want this destination thing, but this is actually calling it. So where do we put that memory? I think we're gonna have to modify this stream T, but that's not the end of the world. And I don't know what happens. Let's just leave this in here actually, because I don't know what happens if it's not available. Read into. Oh, nice. DCD says subtitles are humorous sometimes on technical stuff. Tigerbite says it looks like synced back up now for me now too. And Bruce says I just turned on the captioning. Amazing. Our robot overlords are taking over. Yeah, I mean it's amazing. It like yeah, it's kind of weird that they're like auto transcribing everything, but that's amazing for accessibility, like for people who don't understand or may not understand or can't hear. Like that's awesome that they do that. That's great. In Spanish, it curses a couple of times for technical stuff. Okay, let's keep rolling. I think we can do this. What else do we need to know? Like, how do we... We're going to need like a phantom byte array. to pass in as an object. So what we're going to have to do is we're going to have to make this a little bit bigger. We're going to have to make this UJSON stream T a little bit bigger. But that should be fine. And that should be fine because, yeah, I don't doubt it. Like, it's okay because it's just stack space. Like, just a little bit more stack space so that we can have, like, a byte array object is really not too bad. Okay. I don't remember what these are. This is one thing I like. Johnny says, technical stuff tiger is just one of the amusing subtitling mistakes. Oh, we're running out of time. Don't distract me. Okay, load method. Into this destination, transmit is only passing the transmit buffer object. Oh, we can crib that too. So let's move this into here. And Python read into. And now this destination is going to switch to s.python read into. And do we need to make it a pointer? I don't think so, because it is a pointer. And then we also need to mimic this transmit buffer object thing. This is actually quite nice because this call method is a transmit where you give it a self. It gets self and it gets a buffer, which is basically what read into gets. Stacks face. Yeah, it works just fine. I can keep trying to confuse it. I think load method will error out as well. So let's just ignore the fact that like maybe that doesn't work. And let's go back to pixelbuff and copy this transmit buffer thing. So if we look in here, transmit buffer object is just another thing, which, how is it initialized? Transmit buffer object. Okay, so it's actually a new bytes object of zeros. And this is an allocation here for pixelbuff, which I don't actually want to do, but it makes sense that pixelbuff wants to do it to be dynamic in the length. Whereas I know that I'm going to basically just load in one. So I just want to fake a bytes object, I think, or a byte array object. So now I need to, yeah, this is all sorts of cheating. This is the power of doing stuff natively though. So I think it's in array that it's just a different type code for byte array. Yeah, I think that's true. So if we look here, byte array make new is the same as array new byte array type code. And so if we look at array new, we're creating a new object of type mp_obj array t. And then it's setting timecode, it's setting typecode twice, and then all this stuff. So that's exactly what I'm going to want to do. So if I go back here, I'm going to do this. So we're going to want an mp_obj array. Byte array obj. And then, yeah, I haven't shown this on the stream yet, so this is cool. So s dot byte array obj dot base dot type is going to have to be equal to np type byte array s dot byte array obj dot base dot not base type code equals type code, which I think is byte array type code. I'm definitely like abusing, like I'm not following like API boundaries at all. But that's fine. Free 0 length n, which I feel like free should be 1, but I don't know. Free equals 0. Length equals 1. And byte array obj items is equal to, now this is where we point it back to cur. So the address of cur is where we want it to end up. So we will be doing like, we're going to be reading one character at a time, but we're reading it into an existing allocation. And oh, you know, I was thinking about buffering it though, because we may not want to call. That's right. So the thing I was thinking about is that like calling a Python function is probably pretty slow. So maybe we want to do it like read 32 bytes at a time instead of just 1 byte at a time. But let's not worry about that for now. We'll do one each, and if we need to, like, measuring performance can be really tricky. Okay, so this is the array. So this is s.python read into is equal to the object s.byte array object. So we're handing it self, and we're handing it this static byte array object that we've got. And let's see, what does free do? That's got to be like the first free. Does it say? Free is the number of unused elements after length used elements. Oh. So the length is the current length. That's weird. New byte. Maybe that's because it's an array, you can't like append? Interesting. I don't know why it has that. Let's try it. Okay, so we're basically going to pass it in when we call it, but we don't want to call it here. Instead, what we want is a read function that is going to get called here. So we're going to have to say s.read equals, I don't know, mod JSON, or what is the, like, UJSON Python read into. I don't know. Yeah. And you wouldn't want the parens because you don't actually want to call it. So let's figure out what the function is. UJSON read into takes in let me see. It takes in an object, MP stream object. Which I guess will be null. I should just look at the stream stuff. Hold on. And the truck is going outside again, so it's not you, it's me. Yeah. Sorry for going over time, but I think people like to. Okay, so this is what we're implementing. This read function call. So let's just do that. And here. And this. Okie doke. So I guess what we need to do is we know that this stream object is gonna be, wait, how's it called? We can set it to whatever we want. So what do we want it to be? I think we want it to just be itself. Does that make any sense? Have I lost you? Am I too in the weeds here, folks? Did I dive too deep? Here, I'll close the window since they're making noise. Okay. So we've loaded the method into our Python read into, which knows what object we're talking about. So we don't need to hold on to the object itself. Although we could, because it's what it's going to pass in. So yeah, let's say that it passes in itself because we want access to it. S dot stream object equals the address of S. Feels like I'm begging for recursion, but that's okay. And then let's do none of this. We want to call the method. And we know that we're getting a use on JStream. So let's cast the object back to that. Yeah, I feel like I'm in the zone. That's good. Haven't reached the zone that often recently. And then we called it Python read into, I think. But we could also do the s dot byte array obj items. Since it's handed into us, we could do it here instead. S dot byte array obj dot length. equals size. So this means that this wrapper will actually work. Yeah, this wrapper will actually work for any size. So let's just be a little clearer here and say Lincoln items are set at read time. Okay. And we don't need to raise an error, and we got rid of the assembly. And I don't know what's gonna happen when this throws an exception. Or read into returns the number. Like there's this error code thing. What does the stream thing return? What do you think this MPUnt is? It's probably the number of bytes read. Everybody was chatty for a while, and now I've gone in the weeds and nobody's saying anything. Am I still streaming? I think I am. Yeah. I've put everybody to sleep. Okay, so MP call method and keyword args. I don't know what it returns. So let's just, ooh. It returns an MP obj. So it's the number of args, number of keyword args. So one argument, 0. And I think the function's already bound. And then we pass it the args. And the obj must be just the return. So Bruce says you're still streaming. Thank you, Bruce. Thank you, everyone. I was having an existential crisis. Like, too much time just sitting here talking to myself. And it's got to return an MP small int, so we need to convert this integer back into a regular integer. You all rock. I'm so close. This is awesome. I feel like I'm making progress. Of course, it doesn't actually work yet, so who knows? Yeah, Bruce points out that Friday afternoons are when things ramp up before everyone heads out for the weekend. Yeah, I feel ya. I feel you for sure. Although Becca's back home, and we were already talking, like, I feel like I need to get more work done because it's been not very productive earlier in the day. But I'm also barbecuing tonight, so I might do that. We'll see. Okay, we're super close. We're calling the method. We need to return, but it's an MP obj. Yeah, Johnny points out that it's 1 a.m. in the morning there. That's why Mark went to bed, because it's late. All the Australian folks should be waking up. Australian and Asian folks should be waking up. What is the thing that converts string objects back to regular strings? It's been so long. You don't want to know. So I don't actually have real brats. I've got the beyond brats. And I'm gonna do it. I have a big green egg, so I'll do it on my big green egg, but yeah. It's not actually meat. David says it's Saturday here. Yeah. Barely Saturday, though. Okay, where'd my file go? I got too many files open here, folks. Let's get the value out of that. We could check the type, but, you know. All this unit testing talk. It's just gonna work, right? It's just gonna work. I'll be amazed if it compiles. There you go. That's my point. It didn't compile. S is a pointer. That's true. Here, S is a pointer. Unexpected Maker doesn't count, though. He's on European stream time. Yeah, true. Ah, this is the problem. We don't know the obj array type. So I think we need... Generally, a pro tip, well, a tip is to fix the first errors first, because they can cascade down. All right, almost getting close. We just need to do mp obj from pointer, I think is what it is. And then take the pointer of that. If it compiles, it's fine, just ship it. It's like mostly true that that's the case. Let me walk it back even more. Okay, where's this? Well, it looks like it should be accessible to us. Ah, it's in pi binary. Okay, so we need that too. I do miss that with Python, like the idea that like once you have something that compiles, it's like getting close to being done. Whereas Python, like that's not true. Ah, I spelled pointer out. I was close though. PTR. Okie doke. Missing braces around initializer. No, I don't think I need this initializer. It's just to zero out the memory, but I think I'm setting the value of everything just fine. Let's see what it says. Getting close. You're getting bonus time because that the unboxing earlier took time. But now you're getting the deep dive part of the deep dive. This is turning into a good stream, I think. Haven't had to ban anybody from the comments. Just some awesome folks hanging out. This is why C is worse than Python. the waiting time of compiling. Runs faster though. Do 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 do. Do 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 do. How's everybody doing? Everybody excited about the ESP32S2? Or at least excited about me making micro JSON not require a giant string chunk? Making it more memory efficient. I mean, if CPython's JSON module just calls read, then we should be able to just call read into just fine. Like maybe I could contribute that back up to CPython. Hey, it compiled. Well, anybody want the binary? Should we just ship it now? Let's see what happens. Jim Hendrickson says yes. And I'm not sure what the yes is. The delay is so bad. What did I ask that required a yes? Now everybody's chiming in. Maybe I should try to do that. Well, I see an error code flashing on the device. Oh, that's right. I said excited for the ESP32S2. Nice. Foamy Guy just got theirs. Jim's excited. Okay, let's figure out what the error message we're throwing here is. Oh, oh, oh. I broke the JLink connection. Let me just show the overhead because some people might run into this. So all I did is I clicked right here. I have the USB thing that toggles it, but it blips power when it does. And I do have this power thing going to the board to power it, but I forgot to turn it on. So if you power it, it should be happy when you click back and forth. Unfortunately, I blipped it, so I've got to like, I think I can mon reset from here, and that will get it back going. Oh, I think so. I'm watching the LED. Oh, and you can't see what I'm... What's it say? Doesn't look right. I think it's unhappy. There, I can switch to that view. Reconnect. Reconnect here as well. Reload. Yeah, a lot of lag in YouTube. I could try. There is a setting. Dylan Rice says, I haven't done much with CircuitPython yet, but seeing what you're working on is making me excited to try it. Awesome. Yeah, let me know what you think. Hopefully it's good. I think it's pretty good. Okay, let's see. Let me flip my USB again. And now all the JLink stuff didn't die, so I can do screen and Control D and OS error 537067144. Bummer. Who knows where that's coming from? Johnny, I'm sorry, I cannot take you up on that. Johnny says, I will port CircuitPython to our IoT hub if you do the Quoctel cellular coprocessor support. And I don't think we can promise to do that. Coprocessor support is not easy. But I think, you know, by getting a standard API, that'll make it clearer what people need to do. And then you can build everything on top. Patrick says, I was looking into the ESP32S2's camera support. I was hoping we could get high-res cameras, but the support is for DVP, which is 1080p's 2 megapixel OmniVision sensors, not the MIPI support the Raspberry Pi has to get higher res. Yeah, I've not looked into camera stuff. Okay, so the question is, what do we do about this? I mean, what processor does your IoT hub have? Like, porting CircuitPython is easy if it's a processor if it's just a board definition, that's easy. Okay, so the question is, how do we get... Oh, you know what it might be? Is that in our read into, we're not setting error code at all? Right. So the output here is checking the error code, but if we never set it to 0, then it might error. So let's just set that to 0. It's just gonna always work, right? Okay, so now we have to do this dance of like disconnecting USB because we're gonna reload everything. And Control C and reload. It looks like a memory address. DCD says that number is 2002 FE88, which is indeed a Sandy 21. I think you're gonna have more trouble writing the coprocessor support in that limited memory. in Python at least. But yeah, the CircuitPython port is the part I'll flip that for you, Johnny. If you do the cell coprocessor support, I'll do the board definition. Because the board definition is definitely the easier thing to do. All right. Running again. And now the LED is not flashing like an error code. It looks like it may have worked. So let's click the USB on. And do our screen. Where did I do the screen last time? I guess it doesn't matter. And Control D. Holy moly, look at that. Ah, well, you have external flash, that's good, but it's still not going to be fun compared to 51. Because the 32K RAM is just like not a lot of Python code. It worked. So let's maybe just make it a little more complicated. So let me just pull. I don't think this code.py version is the right code.py. So let's just say escaping. Can we use hello 42? And maybe put them next to each other. Syntax error. Am I not allowed to use those? Yeah. Oh, that's so weird. If I put single quotes, it complains, but it prints out in single quotes. I guess the printout is not JSON. It's how CircuitPython prints it out. But yeah, that's super exciting. I think I'll wrap up with that, but or maybe should I just make a PR? Should we go all the way? Like git status. Like I just modified the file briefly. Git diff. All right, so let's see what we did. We added 2 includes, we added 2 things to the stream. Like, I think if calling the method throws an exception, it will raise just fine. And in fact, we could test this. Let's see what happens if we raise a runtime error and say hello stream friends. Voila. So like the stack trace works all the way from the read into method, which is awesome. Yeah, so if any of the code that ends up in read into doesn't work, that's okay. Here's one thing I think would mess it up. Maybe is if we return something that's not an integer. No, it still works because I think we ignore it, which we definitely shouldn't do. Yeah, what happens if we return 0? Interesting. If we return 0, then it breaks. Huh. Just write the unit test and you're done. That's the thing. We don't have like we don't have a C level. Actually, we could look at that. We don't have C level unit tests, but like I said, Damien does have pretty good, like we inherited from MicroPython pretty good testing. So let's actually look and take a look. Tests. EXT mod maybe? U. Oh yeah, here we go. Json. So the way that the tests work is they compare. Interesting. There's string IO. Is that the way that we should be doing it? I don't know if we have this micro IO turned on. What does that do? I don't remember seeing that. Did I just like make something work that we should just wrap an object with? Let's see. Maybe I did that for nothing. Mod IO. What's in here? It was only created in 2014. IO base. Oh, this looks pretty familiar. Base read write. Creating an array to go into. Calling the method. I think we could just replace our thing with this. Adafruit Metro NRF 5340. Do you mean 52840 or is there a 5340? And does it have native USB? Is that something? Oh yeah, it is. Dual processor SoC. 2 M33s. Oh, it looks like it does have USB. Is it interesting because it has 2 cores? Up to 512K RAM. Yeah, that is pretty interesting. I wonder if Lady Ada's thought about that. You should come on Ask an Engineer and ask her about it. I'm sure she's thought about it already. Bruce got the RISC-V kit with the LCD. I have that too somewhere. And I think it does have USB, which is cool. But it's like pretty similar to the SAMD21. But yeah, anything kid 123, bring it up during Ask an Engineer on Wednesdays. Okay, so it looks like this IO base call is basically what I'm doing. It's interesting. If return code is none, set the error code. Otherwise, get int. So, do I want to just use that? Buffered writer. Buffer reader. Resource stream. Does that mean I do like inheritance? IO base. Text IO wrapper. Bytes IO. Huh. I don't think that's... I don't think I can actually use any of these, but I do want to crib, and maybe the reviewer will tell me otherwise, but let's just crib the call. Let's just crib this. Instead of doing the small end stuff, because this is right, like we could actually end up calling something larger. So let's just do that. And this is ret. Okay. And we don't actually need this else. And that means that we could unit test it if we're going to be good. Although we can't unit test it because, well, CPython won't work with it. So if we unit test it, we would have to do like a different output. And frankly, I don't want to do it. I'm going to be bad and just not unit test it. If you really disagree with me, you can hop on the review and do it, and tell me I really should. Rally the folks to tell me I should unit test stuff. Okay, let's take a look. I did just change it, so let me just manually test it one last time. Yeah, I mean, it's a pretty small change. So I know I'm way over time, so thanks for sticking with me. We're gonna make our JSON, we're gonna improve our JSON module, which is gonna be great. Like, really good. No longer have to, like, Alvaro was talking about like a 1 megabyte JSON file. Like, we won't actually have to pull the whole 1 megabyte into memory to parse it. Now, that if your JSON file is like giant like that, it's probably going to take a lot of memory just to store the whole structure, so it probably still won't work. But at least you won't ever need like one big allocation up front. You'll need lots of small allocations, which should be handy. Anecdata says the new CPython-like ESP32 spy libraries will be a separate in parallel to the current library. I wasn't planning on it. I was planning on just replacing the current one. But that's a big task, and I need to get in the zone next week and do it. I don't recommend the current ones because they're really big. So, I mean, I could do them in parallel. And maybe I'll do them as like pre-release releases. But yeah, I don't really want people to use those older versions. Because I don't think they're not very good. All right. It's working based on the LED, so let's finish this. Git add xmod. Git status. Git commit. Add support to JSON load-s for any object with read into. This way we don't need to load the whole string version of those JSON into memory. Thinking of planning a CAN bus coprocessor for another project. That'd be cool. Definitely need to do CAN bus at some point. People have asked for it. All right, I'm going to create a PR and then I'm going to wrap up because I'm way over time. But again, thank you for folks sticking with me, and I'm glad that we get to actually like end up with a PR on this Friday afternoon here, which is always good. Create the PR. Let's add some labels. Let's say CPython API enhancement. And we do need... technically, we're going to be able to create incompatible code, because if the object you passed in has read into but not read, then it will fail on CPython. But I think it's worth it. Enhancement. Oh, I think we have a memory optimization one. Yep, let's do that. Milestone 6. Create pull request. Alrighty. Okay, thank you everybody. I'll drop that in the link or in the chats. Thank you all for hanging in there for this like bonus 45 minutes on my deep dive stream. I do these streams regularly at 2 p.m. Pacific on Fridays. It's a chance for me to talk about ESP32S2 CircuitPython work and related stuff, such as opening packages I get in the mail and talking about CircuitPython more broadly. I've also spent one talking about my election calendar project as well. So if you're in the US and you want to know when to vote or when to do deadlines for voting, check out my project electioncal.us. With that, thank you all for hanging out. Thanks to all of the Chinese engineers who are getting on board with CircuitPython. You can find me on WeChat I'm just Tan Newt on WeChat. Would love to chat with you there and help you get going with CircuitPython. Again, Adafruit pays the bills for me, so please support Adafruit by going to adafruit.com and purchasing some cool hardware that you see there. They're trying their best to get in stock, and they're trying their best to get orders at the door. I think they're mostly staffed now, so it shouldn't be too long, but please have patience. And yeah, I think that's it. Thank you all so much for just hanging out with me while we hack on CircuitPython. I hope what I find is like people are like, oh, I haven't seen you do that or this. So I hope this was kind of a brief or glimpse into how to add something to an existing module. So I think that'd be cool. And if you have comments about the code, please drop them on the pull request. Always looking for reviewers, and give it a shot and let me know how it works as well. So with that, thank you, and should be around next week. And I'll be a year older as well. So thank you all, and chat with you on Discord. Discord link is adafru.it/Discord there all week. Thanks all.